Welcome to my demo presentation. My name is Jessica and I am a recent graduate student from the SCSLAB at the University of Sydney. Today I will be presenting our demo paper titled Wireless IoT Energy Sharing Platform. Firstly, I will describe the background and problem of our research area. Then I will outline the goal of this demo. Thirdly, I will present the developed application. I will then outline the experiments conducted and the information extracted. At the end, I will present direction for future work. Imagine you're at a coffee shop. Your mobile device is running perilously low in battery. You did not bring your charger and you have an upcoming Zoom meeting. Meanwhile, another mobile user has an abundance of battery and is looking to share their device's energy. You both agree to partake in the energy sharing process. You, as the energy consumer, will receive energy wirelessly delivered from the person sharing their energy, also referred to as the energy provider. This scenario is illustrated here, whereby the consumer submits an energy request to a platform and the provider advertises their services. This scenario demonstrates the concept and process of peer-to-peer wireless energy sharing. This is a type of energy sharing as a service. Some benefits of this energy service paradigm include spatial freedom of the users, as they are not bound to a power outlet, and also the recycling of spare energy, which contributes to a green IoT environment. As the technology of wireless energy sharing is still developing, the problem is that researchers do not have an efficient way of collecting a dataset of the energy sharing process. Therefore, we wanted to create an energy sharing platform which also collects a dataset that will ultimately help developers and researchers build the system architecture of a novel energy services ecosystem. For example, they can efficiently test and measure any proposed technique related to energy consumption and distribution in an IoT environment. In my research studies, I also conducted experiments manually and using the platform to analyze the energy efficiency of wireless energy sharing. I will now summarize the main aspects of the wireless energy sharing platform developed. Displayed here is the homepage of the application, which allows users to either share the energy or request for energy. There are two types of users in the wireless energy sharing platform, the consumer and the provider. Depending on the type of user and their respective needs, they will enter in the specifics of their request. For example here, the consumer has requested 1000 mAh of energy from the provider. Also note that the third field is the monitoring time interval. This is more relevant for research studies in the future where data is collected and analyzed. After the users submit their request, they will connect to one another via Bluetooth. Then the consumer will press a button to confirm their energy request with the provider, who will then accept it. Now the energy sharing and data collection process will start. This brief demo shows the process when the energy request is completed from three perspectives: the consumer, the provider, and the cloud database where the data will be uploaded. As you can see here, the consumer uploads their data first, followed shortly by the provider, who uploads their data into the same document. During my research studies, two categories of experiments were conducted: manual and automated. The common goal of these experiments was to observe the energy efficiency of the wireless energy sharing process, specifically how much energy was lost between the devices during transmission. Both manual and automated data collection experiments were conducted under varying conditions, such as having Wi-Fi and Bluetooth on and a low or high battery state. These factors impact the energy efficiency of the wireless energy transmission. Overall, the process of data collection was far more efficient using the platform, as it was automated and yielded more accurate results. For the manual experiments, common usages of IoT devices, such as having Wi-Fi enabled or having different battery levels were identified. From this, 8 experiments were generated and conducted. The battery level of the consumer and the provider was manually recorded every 5 minutes. From there, the energy loss during the sharing was calculated by converting the obtained current battery percentage to milliampere hours, which is a more accurate representation of the battery state of a device. The overall energy loss in each experiment is represented here. We have verified that the first experiment scenario, where both devices have their Wi-Fi turned off, had the least amount of energy loss. This is because the energy consumption on both devices was the lowest compared to the other scenarios. In addition, the figure shows a pattern of increasing energy loss over time. This demonstrates that as the consumer device is reaching higher battery levels, the charging speed gradually decreases to protect the device battery. 10 further experiments were conducted using the mobile platform, whereby 4 settings were applied to analyze the impact on the energy sharing process. These 4 settings include energy request durations of 6, 10, and 30 minutes, and consumer battery levels starting at 20 and 80%. The contrasting battery levels for both the consumer and the provider were selected to observe its impact on the efficiency of wireless sharing. Contrasting to the manual data collection process, the battery state of each device was obtained directly from the device operating system, thereby improving the accuracy of results. Conducting the automated data experiments confirmed that the starting battery state for the consumer and the provider devices does impact the energy efficiency of wireless charging. The graph presented is a representation of the overall results collected, whereby there is a large difference in the energy loss between the 2 starting battery levels. There is a greater energy loss when the consumer starts at 80% than at 20%. Also, the consumer gains more energy and receives energy at a faster rate when it has a lower battery level. This is because when the battery level is almost full, the device slows down the charging speed. As stated earlier, there is currently no automated way of collecting data to monitor the wireless energy sharing process. Therefore, our purpose was to build a wireless energy sharing platform that collects data. We initially monitored the energy sharing process and collected the related data manually to form a baseline for our project. We then created the novel mobile application. After that, further experiments were conducted using the platform. These experimental results obtained manually and using the platform verify existing research on the typical behavior of energy consumption under different scenarios. The results confirm that the efficiency of wireless energy sharing can be influenced by the starting battery level of the device and having Wi-Fi and Bluetooth enabled. The platform will be useful for future researchers to monitor the process of energy sharing efficiently, especially with the increasing prevalence of energy sharing services. The future direction is to improve the energy platform by considering more edge cases when submitting an energy request and any dynamic behavior that may occur during the request. In addition, more experiments can be conducted with different IoT devices that share energy under a variety of scenarios. Thank you for your time.